that's a new prompt. All right, so bank accounts. Let's go through the motions. I'm gonna fork it. Yeah, I upgraded my Zoom yesterday, so I don't know if that changed the prompt for recording. All right, so I'm gonna copy that URL, go to my terminal here. All right, so in my challenges folder, I'm gonna do git clone, paste my URL, and have that be cloned down from GitHub. Then I'm gonna go into my bank accounts folder. That's the one I got created. Oops. What happened here? CD bank. There we go. And code to bring up VS Code in that directory. Great. Move that around. All right, here we go. So bank accounts, we have some data here. So CSV data in our support folder. Let's kind of read what our challenge is asking for here. All right, so bank accounts, today's focus is OOP design. We've been working with the concept of bank accounts, explore OOP concepts. The goals here be creating classes, creating methods, inside those classes, learning how Python does error handling. All right, so requirements. Let's focus on what they're asking for. So number one is create a bank class. Let me copy both of these requirements over. And let's create a file. So we didn't provide a seed file this time, so let's create some files. Let's call it runner.py to be our main file. And then I'm going to create a new folder. Not sure why the support folder is doing everything here. Okay, new folder. Let's call that modules. In here, I'll add a bank.py, and I know I'm going to want probably an accounts.py also. All right, so we have a bank and account file. Let's kind of see what we need to do here. All right, number one, we want to create a bank class which contains your account class and any future bank account logic. All right, that seems pretty straightforward. So we're going to create a bank class. Keyword of class. I feel like naming it bank seems simple enough. In this case, we're not inheriting from anything right now. So again, these parentheses are optional if you're not inheriting from anything. So I can leave them there and just have to leave them empty, or I could leave them off and it does the same thing. So in this case, let's add them just for fun. And then I'm going to add the pass keyword. Again, the pass keyword just means that there's no functionality here, but it actually does complete this block. If I leave that off, it's going to complain. See that red squiggle here? It's going to say, you need something in this bank class. So for now, I'm just going to put a pass. We'll see what else we want to add there. Create an account, which should have the following functionality. Okay, let's focus on our bank. We need to contain an account class in any future bank logic. So, we have multiple banks, right? Maybe I have an account with Chase Bank, and then I might have, an account with Citibank or US Bank Corp or whatever. There's a bunch of them, Bank of America. So in this case, again, I should be able to create multiple bank instances if I need to, and each of those could have different accounts. Like I might have multiple accounts with Chase, so it's not going to be limited to one account. So in that case, it makes sense to create an init method that has instance variables. In this case, I'm going to have an account that could be maybe accounts plural. I'm not sure how that's going to go, but let's assume we could have many accounts. I'm going to create a list that will store accounts for us. Okay, so there's not too much else that we need to accomplish right now. Future bank logic, account logic, we might need to add here, but for now, just initialize a bank with empty list of accounts. All right, let's go to our account class because that's the more, I think, detailed requirements for now. Create an account class which have the following functionality. So let's create an account class. Account. And it should be created with an ID and initial event. So when we talk about creation, we're talking about the init method, because again, the init method is always called when you create an object for a class. So if I'm creating an account instance, the init method would automatically be called during that time. So in this case, we need to pass in self as the first keyword, as always. It looks like we're going to pass in an ID and a balance. Let's store those as instance attributes. And as always, if there's any questions about anything I'm adding or just any general questions, please stop me and we can discuss it. So again, we'll be passing in an ID and balance. That's part of the requirements when we create a new account. I'm going to drop that in here. Okay. Should have a withdraw method that accepts a single parameter, which represents the amount of money that we've withdrawn, and then a deposit method as well. All right, so we're going to have a withdraw method. Again, these are all instance methods because each account should be able to withdraw and deposit and update the balance itself. We don't have just a general balance that all accounts are withdrawing from or depositing to. So in this case, we have self.balance, and then we're going to be passing in some amount. So this is the withdraw, so we're subtracting. So we'll do self.balance equals the balance minus the amount. Again, we could short form it by doing a minus equals here instead, but let's just do it the long way. And then we need to return self.balance, which is going to be the updated balance for our requirements. This outside function. You guys with me so far? I'll take that as a yes. Again, any questions, please stop me. All right, so we want a deposit method, which essentially does the same thing as withdraw, but instead it's going to add to it. Now, one design decision here, like looking at these methods, they are pretty similar. I could maybe combine them into one method that takes a positive or negative amount. But in this case, this is simple enough. So right now, I don't see any overwhelming reason to kind of combine these into like a shared method that could do the same thing. But again, if there's more logic between both of these that were similar, then I kind of get tempted to kind of create a shared function that both of them could call to kind of centralize that logic. In this case, with deposit, we'll just add the amount. Withdraw, we'll subtract it. So we'll leave this as is, and then we should have another method, acts as a current balance. So this is where one of our principles of class design comes into play. This is asking for the ability to access the current balance of the account at any time. So let's actually go to my runner file and create an account instance. So first thing I need to do is import this module. So I have it in a modules folder. So I'm going to do from modules because my runner file is outside that folder. It's sitting out here. So from modules.account, I want to import my account class. And I'll probably use my bank in here. So I'm just going to do that right now before I forget. Import bank. Okay, so those are both imported here. I know a couple group of students yesterday ran into issues where they had a circular import logic. So let's kind of just talk about how that might happen. If let's say I wanted to use accounts in here. So let's say I want to create a new account. Let's create it in here. In order to use this account class, my bank file needs to know about this class. Right now, it has no idea what account is because that's contained in my account module over here. So in order for my bank to be aware of it, since I'm actually using the class object here, I need to import it here. So I'm in my modules folder. So I'm going to leave that out because bank and account are in the same folder. So I can just do from account, import. Okay. All right, so now we actually have access to the definition of account and that we can use it here. If we didn't have this line, Python would complain that it doesn't know what this is. But hypothetically, let's just say we had a method here that's like get bank routing number. So let's do self and How do I want to do this? Anyway, so if you try to use bank in here, I guess the idea here is if you have like some class variable you're trying to access, like bank.name, that's not even a good example. Bank.location. Sorry for that extra noise. Sorry about that. I always seem to have a noisy street. Anyway, if I wanted to use something on the bank class here, I would need to import bank into this file. So if I do from bank import bank, well, now account has access to bank. The problem here is now we run into a circular dependency where our bank class is saying, hey, for me to know everything and operate correctly, I need to rely on account. But if you go to account, it's saying the same thing in the opposite direction. It's saying, hey, in order for me to kind of exist, I need to rely on all the information that's in bank. So basically, account relies on the bank module, and bank module relies on account. This is going to just go, in a circular logic. Basically, bank saying, hey, I need account. Account says I need bank. That's not going to work well. So usually, if you do feel like you're running into a situation where you have to import both in the opposite module, you're probably designing your structure incorrectly. So in this case, it's fine if bank wants to include account, but then you shouldn't need bank in your account class. Again, if you're running into that, you're going to have to reconsider things. Maybe pull out that logic to another module where it combines bank and account, that you can use them freely. But just be aware of that you can run into circular imports. And I saw some students run into that yesterday, so just want to mention that. Any particular questions on that concept? Sorry, I didn't have a good example here, but okay. So what I was doing here, I imported account and bank. I want to create an instance, so let's just create an account for now. Call it A equals account, and looking at my VS Code handy tooltips, account needs an ID and a balance, starting balance. So let's give it a account ID of 1001, and let's say our balance is say we start off with $500. All right, so that's our account. Now, if I go back to accounts, the question is, or the requirement here, should be able to access the current balance. So my question to some random member of the audience, if anyone wants to answer this question, let's say I just do something like a.print. Oh, sorry, a.balance. Let's just give it to
looking at an instance of the account.
So one moment, Don, I heard you say something about I didn't quite process it. Let me just run this quickly. So if I do runner, I got an error, no module name accounts. How did I screw this up? Okay, so
you might need to have that be dot account.
There we go, thanks. Okay, so I ran this, I created an account instance, and I print out the balance. That's fine, I get the correct answer. Don, you were saying something, I didn't quite catch it. Could you repeat that?
No, that's fine.
Okay, so I got my balance. Question is, why might that, what's potentially not ideal about this?
You're breaking encapsulation because you're directly accessing an instance variable like that. You should use like a getter method instead.
Yep, Jack got it absolutely correct. So this works totally fine. It's not really that dangerous. I'm just reading a value. So it's not a big deal. Like it'd be more of an issue if I try to modify it. Like if I try to, do that equals plus equals 1. Now I'm kind of modifying this value outside of this class. That's definitely a no-no. Like you don't want to, again, we've talked about this before. You don't want to be updating instance attributes outside of their class, ideally. Again, there are exceptions to the rule. Let's not make 100% case here, but usually the data that's contained in a class should only be modified by methods of that class. All right. In this case, we're just printing out this value, so it's not as dangerous. But I would still argue that you probably want to create a method on account that just simply is called def get balance. All right, and this would be a super simple function that just returns self.balance. The question is, why do we do this, right? This just goes back to design principles. So again, it works the previous way, right? Right now I'm just calling .balance. It works. Everything's fine. Nothing's broken. Nothing is inherently wrong. But design-wise, this is not the greatest design. Reason being, again, Jack mentioned it, encapsulation, or that layer of abstraction where, let's say Jack developed this account object, and get balanced is just like, it has some logic in here where, like, let's say anytime you again, this is a terrible bank, but let's say you have a bank account at Encore Bank, and anytime you check your balance from Encore Bank, they take out $1 from your account. That's just their policy. Again, that'd be a terrible bank. I agree, but let's just say anytime you call get balance, it's actually going to update balance and take out $1, right? So this is the policy of this particular account. So one, you should definitely find a new account because that's kind of absurd. But in this case, there's additional logic here that is mandated by the account class. Me accessing balance this way is not quite accurate, right? Because anytime I actually need to check my balance, my bank account is going to withdraw $1 just because that's their policy. So accessing this value kind of just raw without using the methods on the account class is potentially dangerous because this might be invalid, as in my balance actually isn't 500 right now, because since I checked it, it's actually 499. Again, it's kind of a weird concept. I know it's probably not the greatest concept. If you guys are familiar with, like, again, I'm not great with my quantum mechanics, whatever, but there's something in like quantum physics where, like, if you check the position of something, it affects it. Are you guys familiar with this? Is it like
it's the uncertainty, the Heisenberg uncertainty principle?
Yeah. Again, I'm not going to talk too much about it because I'm way out of my realm there. But there, yeah, it's kind of that issue where, like, if you check something, it's going to update it, which is kind of a weird concept. Anyway, the whole lesson here is try to always be mindful of not accessing data from a class directly. Always try to have methods that let you access it. I know Sophia kind of mentioned this about having getters and setters. So same rule. If I need to update my balance, like, I could totally do, a.balance plus equals, let's add another $200. This works fine. It's going to update the balance. My account class is going to work fine. But again, I'm modifying data outside the class. This is usually a red flag, or not a red flag, just an orange flag that says you probably shouldn't be doing this. It's bad design. It will work, but it's not proper OOP design. Okay, so definitely wanted to stress that point. Probably talked about it a little too much, but all right, cool. So I achieved this objective by creating a method. Again, I didn't 100% absolutely need the method, but just better design to have getters and setters rather than making your caller of your function access your data directly. All right, so we could access the current balance at any time. So that looks good. Okay, I think this looks good. Again, we definitely probably should be mindful of testing. So I'm actually going to write some unit tests because I didn't do it last time. So let's write some unit tests. Let's call it test suite. And let's pull that out here. All right, so let's set up a unit test framework. Again, a few steps that we always have to do. One is we got to do import unit tests. Then we want to set up our if name equals main. So again, just to reiterate what this is doing, this check is checking if this test suite is the actual main module that is being executed. If hypothetically we imported test suite into like a runner file, in that case, this block will not execute. This will not be true. So anything in this if condition will not execute. So in this case, we do want to initialize unit test, and then let's set up our framework for test suite. So let's call it bank test, bank account test maybe. We can even create two test suites. So let's actually do that. So I'm going to call it best bank test suite, and that will inherit from unit test dot test case. Put a pass in there right now, and I'm also going to create a separate account test suite. Again, we don't need to do this necessarily, but kind of good to separate it so I can kind of organize my code a little better. So put a pass there. Let's create our bank just currently has no functionality, so I'm going to ignore that for now. Our account, let's let's set that up. So let's do a simple test for create account, create check initial balance. All right, so this test is going to create an account object and it just check the initial balance, make sure it was set correctly. So if I do something like A equals account, let's give an ID of 1, $500 initially. Notice I got that yellow squiggly line. That means this module has no idea what account is, so I need to import that. So we'll do from modules.account, import account. All right, so we create an account, and all we want to do is do a self assert equal, and we know that our a.get balance should equal $500, right? Because that was our initial value. If we remember our logic, we just set that on our balance, and so the initial balance should be $500. Again, this is not the bad bank that subtracts the value each time we check. What else? Let's create one more test. So create withdraw. I'm always terrible with naming things. Create withdraw test. Test withdraw. All right, so we'll create an account. And let's just keep the same, 500. Then let's do a withdraw. Let's say we need to take out $100 for whatever reason. So I'm going to do a withdraw. New balance is going to be returned to us. And in this case, let's assert that new balance is equal to 400. All right, so maybe if I want to clean this up a little bit, I might create variables, make sure I don't screw anything up if I change anything. So let's say initial balance equals 500. The reason I'm doing this is because I have 500 in 2 different places. So it's generally good practice to centralize that. So if I need to change it, I only had to change it one place instead of multiple places, right? All right, so that's there. Let's do the same thing here. And this should be, let's say, withdraw. Okay, as I'm typing, any questions on testing, since we're kind of focusing a bit on testing here? No question?
Is there a way to do that like globally? Can you do that like in the class and then always just have that be the same? Or does it have to be inside of each dev test and then you cut paste that? Is there a way to do that drier? I guess is what I'm asking. Great question. This is something that we have not gone over explicitly. So this would be something from reading documentation, but definitely something I was going to mention in passing, just so you guys know it's possible. So again, I'm just making this cleaner, having variables, so it's again a little more robust and safer. So initial balance minus withdraw amount should be equal to new balance. Okay, so Jack had a great question, or great observation. In this case, I'm creating like an account object each time. That's fine, because that might be what I want. So in this case, if I want this test case to be totally independent of this test case, then I probably want to create objects like this. But if I'm creating like the same type of object, like if I always want to use 500 as my initial balance, how can I do that in a manner such that both of these test cases are still independent? As in, if my withdrawal method actually updates my balance and then this test case runs after it, I guess, like let's say I didn't have this here. If this were using the same account, it's not going to get the same initial balance, if that makes sense. Anyway,
you create an init method under the class account test suite.
So that's a great thought. So there's an option to create init because it's still a class, right? This is nothing special aside from that we're inheriting from test case. But I'm not sure what it threw up here. Oh, is that what's something I have tests? All right, this might be something that test case requires. I'm not sure why VS Code autofilled it.
But yeah, init method, we can create kind of a global variable here. So let's just call it A1 and account. Let's give that account ID of 1 and a balance of 1,000. If we do it this way, now this A1 account that we created is going to be shared between classes. So if I did self.a1 here, and then use that here also, they're gonna, again, these two test cases are gonna kind of rely on each other. That might be what you want to do, so that's totally fine. And just to make sure I make this clear, because I'm probably not describing this the best. So A1 here, let's just do something on it. Let's do, actually, I'm not gonna mess with my test cases here.
If you like withdraw from A1 in one test, it will persist to the next. It's not like a new A1 each time because it's a class self thing. As you change it, it stays.
Yep. I believe, I haven't verified this. I know it's like a student, but I probably should have researched it. I think, so these test cases don't run in order. There's some other order. It might be alphabetical. That's why I named this with 5 A's. So let's give this a try. So let's say this, this will do self.a1. Again, the reason I could use A1 here is because I meant to create an instance attribute here. So I can use that here now. So let's do a withdraw of $100, right? So our initial amount here is 1,000, and we're in this particular test case, we're withdrawing 100. Let's just assume this passes. I'm not going to actually check anything. Let's create another test case and let's call it test BBBB. Again, I'm hoping that these run in alphabetical order, but I could be wrong. Now let's say we want to do something like deposit. And then let's do a self assert equals, let's return the new balance. Right, both of these return new balance, so balance. For the new balance, it should be to self dot. Sorry, I am getting to an endpoint here. I'm just typing a lot. So we have that there, and then we can use this here. So new balance should equal that minus 100. Again, I should probably throw this into a variable. Just throw that there. Okay, so the whole point here is I'm depositing in this case, so that's plus. This should be a minus, and that should be a withdrawal. All right, so this test case, which is named really poorly, is withdrawing some amount, and the next one is depositing the amount. Question is, are these test cases correct? So looking at it, I might be like, all right, well, if I'm depositing something, then I assume that whatever account I had before, which is self A1, that should be whatever initial balance I had plus the amount. But the reason this is not going to work as I expected, let's actually run this and see what happens before I kind of make assumptions. So let's clear this and run my test suite. So I'm going to do Python test suite.py. All right, we passed them. That's actually not what I was expecting. So new balance is always hit the print. So let's print. All right, let's see what the new balance is here. Maybe so there's another method I was going to introduce, but I'm actually curious what we're doing here. Okay, so that is 900, that is 11. All right, I'm actually surprised that that worked.
Could it have anything to do that we didn't like necessarily comment out all the other tests above that? I mean,
no, so good thought, but these test cases aren't touching A1. So we had 2 instance variables here. They are not being touched here. So actually, I'm surprised that this happened. There is a method called setup, which is what I was trying to get at. So setup.
So if you read documentation, there's a method called setup, and there's a method called tear down. Both these methods will always execute between every test case. So these should be utilized for when you want to like recreate an object. I'm actually, again, a bit surprised that this works. So I'm not sure how this gets initialized and works correctly, unless I'm missing something. Because my withdrawal method worked, got 1100, my deposit got 900. I thought both of them would have kind of interacted with one another. But anyway, so there are two methods, setup and teardown, which is meant for doing what we're kind of doing here, where we want to recreate the same object. So in this case, I could pull out these values and put it in setup. So let's see if I do that correctly. And then I can use those here. So I guess long story short, we can use the init method to create instance variables and share them across test cases. But I guess in this case, they're not actually shared. So before I go too much into a tangent, let's kind of take a step back. So if you're curious, read more into setup and teardown. Again, setup always executes before every single test case in your test suite for that class, and teardown executes for after every test case runs. So they can be useful if you're trying to do particular things. Again, I'm not sure why this A1 is kind of persisting. Let's try one more thing. I'm going to print hello here. Let's see how many times my init method actually gets called. All right, because we're using self.a1 here. We're updating it like so, and with withdrawal. So to run this.
Self.a1.
Yeah, I have that down here. So these two methods are my actual test cases. AA and BB were the ones I was kind of messing around with. All right, so these run. Yeah, so it looks like it's calling our init method every time also, which again, I'm a bit surprised on. I thought it would create our class once. So it seems like I need to read some documentation myself. So let's kind of ignore the last 5 minutes. Apologies for that. But yes, to answer your question, you can kind of create an instance attribute and use them for your test cases if you don't want to keep creating the same account. Like if I'm going to do this in every test case, then I probably want to pull that out into init method or my setup method instead of just doing that over and over.
Why don't you initialize them outside of the init method?
If you do it outside, I think that is probably, yeah, I think that might be the way to kind of share. If I do an A1 equals account, I think in this manner, I should be able to use A1, sorry, not itself. So if I create an account out here, let's give an ID of 2 and balance of 1,000. I wish I hadn't deleted all that stuff. All right, last test, I promise we'll get back on track. All right, so I have AA and BB. There you are. And then Sarah's suggestion was let's create a class level attribute. So this can be shared between instances. We have one account, and in this case, we can call self A1. That's fine because we are accessing the class level attribute. So in this case, one of these test cases I think should fail because once we either withdraw or deposit one of them, our initial balance is still going to be 1,000, even though that the actual balance is not 1,000. So let me run that. And what's this? Line 40. Oh, I took that away.
Ankur, I have a question.
Yep.
Would it be, I mean, if to take into consideration like kind of your fear, would it be better like if we were passing that into that specific like test suite to maybe just test like against the general like returns an integer, you know what I mean, versus like a string, you know what I mean?
Not quite. So do you mean passing values in here?
Yeah, exactly. Like if I understand correctly, is that what Jack was kind of referring to by kind of just trying to limit how much we're repeating ourselves?
This 100% has answered it with that setup and tear down. Like that was a thing I was wondering about, is like, how do you handle stuff that is expecting like imports and exports and like user interface stuff? And this is how you can get a same standard account object or bank object that you can do certain things to and get certain expected results based on your code from. Sorry.
Yeah, so I'm not sure if you could pass in values here, because again, these test cases are being called by the unit test framework. So I don't know if you have control over that. Again, I'm not too well versed on it, so I'm not going to rule that out entirely. But I would guess that you can't really pass in values here manually. But kind of review what we did over the last 10 minutes. Sorry for the long tangent. Basically, if you create class level attributes, which I've done here, that allows you to share the same instance across different test cases. So if that's something you want to do, you can do that with class level attributes. If you create instance level attributes, then you can reuse basically the same object, but they're not shared. So basically, the object you create, the instance attribute, will be destroyed after the test case is ran. And I need to read documentation as to why that's happening, because I thought this class would be initialized once, but that is not what's happening.
No worries. Thank you.
Okay. All right, so that's our testing. Kind of let's get back on track. But before we get back on track, let's take a break. So it's 9:25. Let's take a quick 5-minute break, and then we'll get back to actually designing our classes and taking care of everything else. Resume the recording. All right, so we wrote some simple test cases. Here we just have a couple on our account. We're checking initial balance and withdrawing and checking that the withdrawal method works correctly. So we ran those, just run those one more time. Test suites, we ran 2 tests, got okay. So okay, we have some preliminary tests created. We probably shouldn't create one for deposit and maybe individually for get balance, but let's kind of proceed with our main task. So, sorry, I have a lot of tabs open. Bank accounts. All right, so we accomplished these tasks. Again, we probably want to write more test cases, but let's kind of get deeper into this. So error handling. This is the idea of using that try except structure that we've dabbled with before, so we're just going to use it again. A new account cannot be created with a negative balance. So that's something we need to test. This raise keyword, I definitely talked about that at one of the challenges, but good to talk about it some more. So let's do that. So our requirement here is that a new account cannot be created with an initial negative balance. So we should raise an exception if that's the case. So before we set it, we should check it. So if balance is less than 0, so I guess we could have a zero balance, but not a negative balance. Let's raise an exception. So this is something I didn't do last time. Last time, I believe I just did something like some string. Normally, you want to use an exception object. So Python has a base exception object that you can just use. And here you could pass it a string. So let's say we could pass it a value of invalid balance. Please set positive. I don't know. All right, something like that. So we raise an exception. This is basically going to abort this function and return from our init method. So if we are raising an exception, we should always wrap anything that's calling this. So in this case, init method, anything that's creating an account instance should always have a try except block, because an exception could be raised. So I go back to my runner. This again is not protected. So if an exception gets raised currently, let's actually see what happens. Let's do a negative 500 balance. Let's run this. So Python runner. Our application kind of crashed here. Notice we got some bad output. Our application stopped running because we got an exception. It was unhandled, as in an exception was raised and no one took care of it. So our application was like, all right, well, I can't go on. So the proper way to handle that is to create a try block and then have an except block. So this is going to catch an exception, and I'm going to alias that to E. And so now I can do something like, I can just print it out. I could do print out E, and that should have the message that I was passing here. So now if hypothetically this fails, which in this case it will because I have a negative balance, this except block will catch it. And so we're gracefully handling the error, and we can do more stuff here. So if I want to just do like, print donuts are yummy, this will still execute because we handled the error and said it's okay. Not like, let's not crash our app and let's proceed with traditional logic. So if I do this, notice I still got that error, invalid balance, please set a positive amount. I still got donuts are yummy because this does not abort the execution. It just says, okay, I'm going to handle it. Everything's cool. Let's proceed.
You're basically telling the computer to expect that possibility.
Yeah. So yeah, if an exception gets raised, we're just saying we're handling internally rather than having like the application say, all right, I don't know how to handle it, so I'm just going to abort operations. Is everyone clear on the usage and the structure of try except? It is pretty important to kind of understand the concept here and why it's important.
No, that's awesome. Couldn't quite get it to work when we were messing around with it yesterday, seeing it here and how it flows. Thanks.
Yeah, it was my bad. Again, in a previous lecture, I didn't raise it correctly. So you want to raise an exception object. Again, there are different types of exceptions. So you can raise like a value error. That might be more appropriate here because this is actually like a bad value. So a value error. The reason there's different types is because theoretically, if I go back to my runner file, I could have multiple except blocks. So I could do exception as E. I guess I could have left it as it had before. But I could catch a value exception here and do something different. So let's say if it's a value error, I want to print it out. If it's unknown exception, then let's say I want to actually abort my application. How do I do that? You want to know that? So exit, exits. Okay, so if I get a value error, that's something I might encounter. If it's some random exception, like just something else went haywire, I still want to actually abort my execution. So let's maybe give that a try. So if I have ID, let's say if our ID equals 666, that's going to be just a exception gets raised. All right, so in this case, I don't know how to handle this, so I'm just going to actually abort. But if my balance is negative, then that's okay, as in we don't want to crash our app. So now we have different types of exceptions we're raising. One is a generic exception, another is a value error. Let's kind of see how those operate. So in this case, we have a valid account ID, but a bad balance. So if I run this, nothing should change. Notice we still got invalid balance, but let's pass an invalid account number. So in this case, 666. That will be checked first, so this won't actually check, but let's just make that valid. If I run this now, notice I got nothing outputted, so maybe I wanted to print E here. So notice I got bad account number. That is the exception we raised here, but donuts are yummy did not get printed because we exited in that case. So again, you can catch multiple types of errors. It just gives you more granularity. You can even create your own exceptions. So again, there's nothing stopping you from doing class my exception. And then you would want to inherit from exception or whatever your base class is, and then add functionality. Again, that's the whole idea of object-oriented programming. You can extend or specialize anything that exists and add on to it or do whatever, customize it the way you want to. Any questions about, again, try except, just the idea of error handling that we've introduced here?
Practice for integrating that into the rest of your code. Say, like you use A further down in your program, like what would be the thought process? Because now if you get an exception for A, would you just exit out at that point? Or like, how do you robustly handle errors?
Great question. Yeah. So again, if usually, again, you're going to want to use try except a lot. In when we're just developing and learning, we're not going to be that I guess
that mindful of using try except as much as we should be, because again, we're not really delivering this application, your coding solutions or applications to external customers. So, but to answer Sean's question, in that case where you need to use A, all that logic should still go here. So if I want to do, withdraw 100, anything that relies on A here should be still in the try block, because if this line throws an exception, this line will not be executed. Basically, this line will throw, this block will handle it, and it will proceed down here. So logic that's down here does not rely on A, so this should run. Anything that relies on A should be still in this block. So if you want to deposit, anything you're doing here, because let's say hypothetically my withdraw throws an exception, throws like a value error, then my deposit should not run just because something went wrong. I want to proceed. But if that's not true, as in let's say regardless of my withdraw fails or not, I still want to deposit money, I could do that here. Okay, so this structure is saying try to create an account. If you successfully create an account, try to withdraw $100. Regardless of if that fails or passes, like if this throws an exception, we're still going to deposit. Sorry, I'm lying about that. Finally versus else.
So we could also throw a value error in the withdraw method and it would use the same except.
Yep. And I think that's actually one of our requirements. So let's actually make some progress here. The withdrawal method does not allow the account to go negative. It should output a warning and return the original unmodified balance. I'm actually going to throw an exception here. So I'm going to kind of deviate from what they're asking for, just to kind of use exceptions a little bit more. So withdrawal method, let's say if we're going to go negative, I'm going to raise an error. So let's do that in our account. So let's go down to withdraw. And so it says we don't want to update the balance initially, so we want to check it first. So if self.balance minus amounts, if that winds up being less than 0, I'm actually going to raise an error. Let's make it a value error and say cannot withdraw amounts. Yeah, we can make them more detailed, but anyway, if we're about to go negative, we don't actually want to update the amount, and we're going to return, we're going to raise an error. So this is not going to return anything. So in this case, if I go to my runner file, again, this will handle that exception that gets thrown here. So let's make a good account ID. This will throw if I make it 1,000 because the initial balance is 500. But we can still deposit, even though our withdraw fails. The finally block will always execute no matter what happens with our try block. The else block is another case. So let's say a withdraw. So I'm just adding some essential logic here. All right, so this is the entire I guess, gamut of try except. There's also an else and finally you can tack on. So try, this will attempt to execute. Except will handle any exceptions, any raised exceptions. Else will only execute if the try block succeeds. All right, so important to know that this part right here will only execute if all of this is successful. If any of this raises an exception, the else block will be ignored. The finally, on the other hand, will always execute. All right, everyone clear on error handling? Again, we don't use it too much with our code in this cohort, but just be aware that this is an important concept for software development. Again, just writing safer code, especially when you something more critical is online. Like in this case, we're just writing a fake account thing. But if this were like JP Morgan Chase and they're creating software for it, they probably don't want their banking software to crash because that's like a global catastrophe at that point. Okay, so that takes care of error handling. So that was this part.
optional. Let's create an owner class. Yeah, I'm going to do this. I don't think it'll take too much effort. So I'm going to create an owner class, which basically is like an owner of bank accounts. Add the owner property to each account to track information on who owns accounts. Account can be created with an owner, or you can create a method that will add an owner after the account has already been created. Okay, so I'm going to create a new file in my modules folder. Let's call it owner.py. I'm going to go here, class owner. I'm going to do this real quickly. Inherits from nothing. We'll do an init method. And let's say we're just going to track the name, maybe address, and that should be good for now. Self.name, name, and self.address. All right, pretty simple class here. Again, we probably add more functionality, down the line if our application calls for it. For now, just storing a couple pieces of information about our owner, and then we want to include that here. So we're going to do from.modules import owner. Now, again, just to highlight our design patterns. So in this case, an account has an owner. It's not, it's not inheriting from an owner. It should not inherit from an owner. You can still get it to work because, owner is still going to provide this data, but it's not proper design because accounts, again, is not related to owner in that capacity. An owner is part of an account. So in that case, let's pass in an owner here. And I think our requirement said this could be optional. So I'm going to have a default parameter here. So if I don't pass in an owner, it's going to default to none. If I want to pass it in, I do have the option to as a caller of this function. Let's do if, I guess, self.owner equals owner. And then I think the other requirement was you should be able to set an owner. Def, don't forget your self keyword. Again, this is an instance attribute or instance method. So do self.owner equals owner. All right, pretty straightforward. Again, comes down to design decisions. Like maybe we want to prevent a new owner from being set. In that case, we might want to check if an owner exists. So let's just pretend that you can't change the owner of a bank account. So in that case, I'll do a quick check. I'll do if self.owner is not none. Let's raise another exception. All right, so this prevents us kind of like for like a hacker coming into our account and setting a new owner and taking all of our money. In this case, this particular account doesn't allow you to change ownership. All right, you guys with me still? Any questions about anything we've coded up? So we've handled part one, but I want to make sure we address any questions that you guys might have. So what's on your guys' mind right now?
I'm still just marveling at the setup thing for test suites.
Got it. All right, so I'm just gonna do an incremental commit here. We accomplished some good stuff here. This is say completed part one. Not sure why I capitalized P, but we'll go with it. All right, that adds a bunch of stuff. It looks like I forgot to add my Git Ignore, so that's something I want to do now. Let me just delete my PyCache. Add a Git Ignore, always good practice. So .git ignore. I want that in my main level. This should ignore PyCache. Okay, so let's do a git add, git commit. Okay, and then sure, I'll just do a push right now, just for fun, in case my computer crashes. Who knows? All right, so I did an incremental commit to Git, also uploaded to GitHub. So I have those save points in multiple locations. Let's go to part two, and hopefully we can knock that out pretty quickly. So part two, learning goals, create and use class methods, use a CSV file. All right, so we get more practice with using CSV files. Let's look at our requirements. Update account class to be able to handle all the fields from the CSV file input. For example, manually choose data, yada, yada, yada. add the following class methods. So class methods, again, don't rely on any instance. They're just general methods that you can call without the existence of an instance. So we want to be able to get all accounts and find an account by ID. Let's transfer that over to our account here. Get more space, and let's go down here. Okay, so let's take it piece by piece. Update the account class to be able to handle all the fields from your CSV file. So let's take a look at that. Accounts.csv. There's no headers here, so that's unfortunate, but I'm guessing this is account ID. This is amount. This is the date, and this is the time, I'm guessing. I hope that's right. Yeah, so it looks like there's a date time value here. Okay, so account ID and amount is what we're going with. All right, so let's do that. So this is going to be a class method, I think.
Turns out the amounts are in cents in that file.
Is that right? Yeah, we could assume that. Again, they didn't specify, so we kind of take liberties with the data.
Actually, someplace they do specify that everything is in pennies.
Oh, okay, sorry. Yeah, I'm kind of scanning this file, so appreciate you guys kind of reading for me. All right, so that's gonna be in pennies, so we'll make sure we handle that appropriately. Okay, so we want all accounts. Let's create a def all accounts, and that's gonna be a class attribute. So I'm gonna use CLS, and let's add our decorator for class method. Again, so the name here, this is totally up to you. You can name this donuts if you want, but per convention, we name class methods with a parameter of CLS, and that refers to the actual class that we're dealing with here. So count is a value of CLS that's going to be passed in. That is not going to be an individual instance that's passed in when we call this method. So in this case, we want to read a CSV file. So let's import CSV. Give us easy access to that file. And then we want to make sure I'm reading this correctly. All accounts should return a collection of account instances represent all accounts described in CSV. I'm assuming all accounts is going to read in the CSV file. I'm not sure we need to separate that. See below for CSV specifications. Got it. So integer, okay, and pennies and date time one. Okay, cool. So let's deal with this. We're going to do with import OS with open, what is it, os.path. I always forget this. Anyone remember what goes in here?
Yeah, hold on.
That's all right. I'm going to do it the lazy way. So Tom talked about it. You usually want absolute pass instead of relative pass, because if this module moves, you're going to kind of screw up. But I kind of want to just get this working, so I'll do it this way. Port slash. All right. So again, usually you want absolute pass, but I'm forgetting that syntax right now, and I don't want to spend the time on it. So as file. All right, so for alias, all right, so we open the file. In here, we want to read the file, so we're going to do reader equals accounts file dot read. Right, so I do CSV reader accounts file. All right, so basically we're using the CSV module as a reader method that's going to read this file and give us a reader object. Let's call that data. Then we want to loop through for line and data. Let's print it out and just see what we're actually getting in line. And okay, so I'm going to test that out quickly. Go to a runner file,
let's comment this good stuff out. Let's just call accounts. That's our class. Again, we don't have an instance here. We're calling a class method, so we call it directly on the class name. Again, notice the capital A, because we name our class with capital letters. I'm going to call all accounts, and hopefully that doesn't blow up in my face. But that's why we incrementally test. So I'm going to do Python runner and no modules.module. That's not good. All right.
Would it be modules.owner?
I think I just need to do owner here. Okay, no file or directory and support accounts. All right. So
Because you're calling the account, you need a classes dot owner there. It just depends on like how you get into that folder is where that initial classes has to be. So since your runner file is out in the root, and you're calling the account class method from the runner file, the account here now has to have classes dot owner in it.
Gotcha. Yeah. Again, so using relative paths, that's a reason not to. So as Jack was saying, we're using our runner file. So that runner file is the one that's actually using this path. So relative to the runner file, we're at the current directory, not the parent directory. So again, relative paths, not a good idea. Sorry for being a bad example here, but we were able to read the file with that change. So thank you, Jack. Yep. So this is the data. It looks correct. Notice we get an array. Each value from the row is put into a different index in that list. So we have account number, value in pennies, and then date opened. Let's see if we could actually use that data. So going back to my account, looks like we need to have a self dot open date. And that would be open date that we pass in here. So again, for when you use default parameters, they have to be last in your list. So it can't just slide open date after it, because open date is not going to have a default parameter. We're going to mandate that you have an open date.
That caught me up for like 15 minutes last night.
Yep, can definitely be tricky. But getting good practice with it, I hope. All right, so we have this data. We need to extract that data and put it into an accounts object. So let's create probably want to do this on the bank level. So we've not used that bank class. So I'm actually gonna bring that into the fray. So I think it makes sense to have a class level attribute that's accounts because your bank owns the accounts. So I think it makes sense to have it here. And then if that's the case, maybe we want to, I don't know, I'm gonna make an executive decision. I'm not sure if, fine, we keep that there. This can call, so I was thinking maybe we could put the all accounts into my bank because our bank kind of owns it, but maybe the account can do that logic. I'm not quite sure what's best here. So self account. Sorry. So accounts here should be an instance attribute. Question: why should this be accounts here versus accounts here? Can someone tell me what the difference is here?
Not all banks are going to share the same accounts. Each bank has accounts rather than banks in general have like accounts that they share across multiple instances of bank.
Yep, Jack's got it. So again, we might have JP Morgan Chase, we might have Citibank, we might have Bank of America. They're not all going to have just like one generic list of accounts, right? They each individually have their own accounts nested within the bank itself. So that's why we don't want a class level attribute, because there's not just one bank data that's shared across all banks. Each bank is going to have a list of accounts. So in this case, load accounts is going to call accounts dot all accounts, and we'll just store that return value. So ideally, all accounts should return a list of accounts, but let's protect ourselves. Like, who knows, maybe the CSV file will fail, maybe our parsing will fail. Let's just add more protection for ourselves. So except exception E. All right. We could also re-raise it. So we could raise another exception here. So if we get an exception, and let's say we don't know how to handle it. So the, I guess, more common case would be the value error as E. So maybe we are expecting we might get a value error. In that case, we could handle it here by whatever, just printing out an error message. But if we get another type of exception that we weren't expecting logically, then we could re-raise it and have someone else handle it for us, like the next level up can try to handle it. So there's different, different levels might handle your exceptions at different times. So just know you could re-raise if you need.
I kind of have a question, Encore.
Go for it.
So let's say, for instance, worst case scenario, there were multiple exceptions that were handled as E. When we run the runner file, would that print out all instances of that specific, like those multiple occurrences as E?
So we're doing this as E. It's kind of creating like a local variable. So this E can only be used in this block here. So if I create another except value error as E, this E is going to be only local to this right here. So this, again, only going to exist in this block. If I try to use E down here, I don't think that should be allowed. But maybe I could be wrong.
The other thing is that once the exception is handled somewhere, we're done with it. It's not going to go to any other exception handler.
That's true. Again, it's our choice. We could re-raise it if we need to. We're in control of that exception. But this E value, that's a good question. So we have one of these blocks, we'll handle it. But it looks like that E is going to be available here, which is kind of surprising. Runner. So take a quick detour to answer that question. If you guys don't mind, I want to see if I could print E here. Oh. Yep. Okay. So yeah, this E is local because line 16 trying to access E. Again, that only exists in this block. So it's a local variable. So you can name them the same. You can name them differently. It's not going to matter outside of that block. Does that answer your question, Kyle?
Yes, absolutely. Thank you.
So just think of this basically like, again, if this were a function, this would be a parameter that's being passed into that function. So you could access that value as much as you want in that function, but once that function goes out of scope, that value also no longer exists. Again, this isn't a function, it's a block of code, but same concept there. But thank you for asking those questions. Let's get back to what we're doing. So we're trying to load all accounts. Let's see if we could do that. So we have our line, we need to convert that to account objects. We can't use dictionary reader right now because we don't have a header, but we can maybe try to parse it ourselves. So what do we want to do here? Line 0 is our ID. We convert that to an int. Amount, balance is an int that's going to be line index 1 divided by 100 because it's in pennies, and let's say we want to store them in dollars. What else? And then we have dates.
It took me a while to realize that they were being pulled out as strings.
Yep. Yeah. Easy to kind of assume that you get the right type, but yeah, all text files are going to be string data. There's no data types in string data, so I'm not sure if date's going to work, but let's give that a go. And date does not work. At the Googles, I'm not sure how to convert. So there's a date time module and a
str p time. Okay. I don't want to go down that path, so I'm just going to keep it as a string. If we need to actually use that date as something, then we'll get back to that. So we're just going to store the date as a string if we're cool with that. All right, so we have those 3 values, and then we're going to try to create an account object. So our return is going to be accounts, empty list, and then accounts we're going to add to it here. We're going to create an account object, and that's going to be takes an ID, balance, and open date. All right, so notice I could use the CLS value here. This CLS again is another, it's basically holding account there. So you could use account here to kind of be explicit. I'm actually not sure what best practice is. Since we do have a class variable, I assume you should be using it. So that's why I'm using CLS there. I guess the benefit there, if you want to think about it, let's say I need to rename my class. I name it account super. In that case, you know, I don't need to update my value here. CLS is still going to be the right thing. Versus if I use account, then I'm going to change in multiple places, as we talked about. That's not good code design if you need to usually go to multiple places when you make one change. All right, so that should be reading our CSV file, creating account objects right here. That's creating account objects. Maybe let's be a little more clear about that, just in case you know, we read this in the future and it's not as clear. So creating account objects there, and then appending account here. And then finally, after we're done reading all of our lines, we want to return our accounts. And this method is a class method that's being called from our bank. So we haven't created a bank object yet, but bank object's going to call load accounts and then basically populate accounts. So let's say it returns it also. Return accounts. So accounts. But if we get an error, let's print that error and let's actually return none. We're still returning something. So now we can check our return value. If it's none, then we know that some error occurred, but was handled. Otherwise, we have actual accounts. So let's go to our runner. I'm going to comment this stuff out just to get less output. And let's get more space here. All right. So we're going to create a bank. Let's call it bank B. And that takes in no parameters right now. B is just going to call, let's see, for, so we want to see all the bank accounts for this bank. We're going to call load accounts. And then if accounts is not none, again, there might have been an error. We don't know. That's kind of encapsulated here. So we don't need to know what error was. We just need to know if we have the correct result. For a and accounts, let's print out. Yeah. One thing I totally forgot about that usually is good practice is I want to define a str method. The reason being is this just provides better output when you print out the console, or if you have a UI, it'll use this method. So let's print out something useful. Quickly, let's return a string that says this account is owned by self.owner.name if self.owner is not none. Let's make this a little better. Okay, so I was using a ternary here. I don't want to make my logic too complicated, so I'm going to break that out. It's not none, else no name. All right, it's owned by owner name, and the balance is self.get balance. Since we have a getter method, we should just use it. I mean, we could use the balance straight up, but I think it makes sense to use a getter if we have one. So call self.get balance, close our string, and let's give this a run. I haven't paused for questions, so want to make sure haven't lost anybody along the way. So questions, thoughts, comments, anything that you guys did differently or anything that was unfamiliar or kind of seemed weird in what I've coded up.
So what's the purpose of using that string dunder method instead of just using like a try and accept block?
So those are two different concepts. So try accept, sorry, maybe I misunderstood your question. So try accept is for error handling. The str method is just simply for outputting like a string version of your class.
Oh, okay, my bad. I just misread that.
Nope, no problem. Always better to ask than be unsure. So yeah, again, this method is optional. It's just good practice to have, especially when you're developing UIs. It's going to use this method kind of automatically. So let's do a runner UI. Okay, there we go. I got a bunch of output. So it looks like all my accounts loaded successfully because if I go back to my bank, no exception was thrown from all accounts. So that means I returned all accounts here. And then in my runner file, I'm basically looping over all those accounts. And I'm just doing, again, printing A. The reason I get this nice output is because of that str method that I just added. So it looks like, again, we have no names in our data. So that's why we have no name here. And we have the current balance. So it looks good. Maybe want to put a $sign there, assuming that we're dealing with dollars. And dollar. Okay, cool. So that took care of something, hopefully. Right, so we did CSV loading. We did this. Let's do the find method, and then I'm not sure what part 3 is asking about, but might kind of halt our progress. Okay, so there's an inheritance going on. I think it might be worthwhile. Let's kind of power through the next chunk, and then hopefully we could wrap this up shortly. So, all right, so we want to find method, and that should be on our bank. Because again, our bank is the owner of our accounts. So I'm just going to add it here. Find account ID. And we pass in self and ID. Self.accounts.find. Find. Upon list find. All right, let's do a for loop. I don't think it's going to work the way I want to. So we have accounts for A and self.accounts. If A.id equals the ID we're looking for, return that account. Else return. Complete's getting me here. All right, so pretty straightforward. We have a list of accounts. We're looping over them, matching the IDs. So each account has an ID. We're passing an ID we're searching for. If we find it, return that account object. Also return none. Okay, so that should take care of that. Let's quickly verify that. Let's go to our CSV file, which was in support. Let's see if we can find account 15152. And that should have a balance of some gigantic numbers. That's, I think, our highest value account. Yeah, let's give that a try. So let's call our bank. We will find account by ID. The account ID was 15152. And that's going to return an account. Probably name it something else. If a found, again, we need to make sure we actually found something is not none. I guess in this case, we could just print it out either way. So print a found. All right, great. Let's give this a run, see if we find it. I'm gonna comment this out. Okay, so the last output here, we got this account is found by no one, and yep, we got that balance that we were expecting. So it looks like our find method probably working correctly. Again, probably want to add some unit tests, make sure we make this a little more thorough. but we're going a little fast right now, so I'm not going to bother with unit testing at this point unless you guys want to see it. So please speak up if you want to see it. Okay, cool. Let's kind of clean up our output here. So let's get rid of line. And okay, let's go to part 3. So before I go to part 3, let me do a quick commit, git add, git commit.
Do you mind if we take a break?
Sure, absolutely. Yeah, let's take a 9-minute break since we took a shorter break earlier. Yeah, be back at 9:25. I'm just going to commit this, and then we'll try to tackle part 3, or at least talk about it, and then get to our main lecture for today.
I'm going to plan on 10:25.
All right. Yep. 10:25 sounds good.
Hey, Unker, dumb quote question. Is there like a good source for like unit test like philosophy and like stuff? Because I've been using it a lot to help write code, and I got a blast like out of the setup that solves like half my questions for what we're doing now.
Let's talk about the last part here. So again, left out some of the CSV data reads there, but here we want to talk about inheritance. So that's something that again is a OOP design principle. We're going to implement a savings account, and then also there's a money market account that we can implement. So the key thing here is that these are specialized accounts. So we have a generic account over here that we created. Right, this account class has a lot of logic in it. All of this logic should be available to any of our other accounts that we create, but those accounts will have additional specialized methods or data that they're going to implement. So in that case, I'm going to create a new file. Let's call it savings account.py. Okay, and this will create a savings account class that's going to actually inherit from account. And we'll just pass right now. Since we're using account here, we need to import it. So we do import account. All right. Sorry, I had that backwards, don't I? From account import. All right. So, so we have this savings account. Let's take a quick scan of what this needs to do. So initial balance can't be less than 10. Raise an error. Update withdrawal functionality. So savings account, when you do withdraw, it's going to take off $2 extra for withdrawing from the savings account. So let's kind of do this part. Might skip some of the stuff down here, just in the interest of time. But let's kind of see how inheritance works there. So we're going to create an init method. And the reason we want to create an init method is because we have a new requirement for savings account. The initial balance cannot be less than 10. Whereas our base account, our requirements, it just can't be a negative number. Savings account needs at least $10 when you initialize it. So that's something we're going to have to check in our init method. Notice that VS Code was quite nice to me. It added this super method call. The reason we need to call this is because we're inheriting from account. So again, account has all that good stuff baked in. If I go back to my account file, we have all of these values that we're storing. We have ID, balance, open date, and owner. This is stored again in our base class, which is account. So we still need to call this init method ourselves from our derived init method so that all this stuff still gets initialized properly. We don't want to we wouldn't want to copy this and paste it, or will we? Savings account. This would be bad practice, right? Because this is adding some redundancy. We have repeated code. So, if I wanted to be like I don't want to call the base class, I want to do it myself. Well, this would work, but it's bad design because again, why are we setting ID here and then also setting it down in our base class? Like that's just two different places doing the same logic. So if you do need to do something different, then you can. But if you're going to do whatever the base class is doing, that's why you should be calling super, which is going to call our base class for us. But here we do have one extra piece of logic we want to add, which is the whole reason we added this class. And I would say we could do that before we call our base class. Actually, no. I think calling our base class first makes sense to me. If balance is less than 10, then let's say savings accounts need $10. right, so we have another check. This is specialized to our savings account. So that's why we created our init method. Everything else we're inheriting from our account. So like the checks that we're doing down there, those are still fine. Like if it's negative, that's still fine in this case, because if it's less than $10, it's going to be here. That's going to fail also. So okay, that seems good to me. Let's see what else we need to do here. Update.
Hey, Ankur,
Yep.
should your super init call be beneath your exception?
Good
Does it
question.
make a difference?
It doesn't really make a difference, except I lost my copy and paste. It doesn't really make a difference. This is what I generally say as advice. If you have derived methods, so in this case, init is a derived method. If you can call the base class first, you should. There might be reasons, like logistically, like there might be a reason to do this before doing any of this. But if you don't have a good reason, I recommend calling your base class as the very first thing you do in any derived method. But again, sometimes it might make sense. Again, like I'm trying to think of a good use case, but I'm struggling on the spot. But there might be a reason why we need to check something. Like let's say, yeah, I can't think of a good reason right now.
I guess my question, my follow-on question then is, that makes sense, but so if you raise a value error after you created a instance, is that still going to be a valid instance, or is it going to, what's going to happen?
That's a great question. I think we could definitely find out. So I think the question is, we're calling the init method on our base class. Is that going to kind of like create a account object that's not a savings account? I don't think it works that way. So this isn't actually creating an instance. It's just initializing the instance that's going to be created. So we're only creating a savings account instance. So this is, again, not creating like a temporary account instance. But we can try it out. It's definitely a great question, and I don't 100% have an answer. So always good to check. But yeah, so rule of thumb, always call your base class first if you can for derived methods. If you need to call it. Sometimes you don't want to call it at all. That's really fine. We're going to create a withdrawal method. Just to review some of our inheritance topics from last week, we're creating another method with the same name. So savings account has a withdrawal method, and my account base class has a withdrawal method. What is the buzzword for that? What is the technical term for what we're doing here?
MRO.
What was that?
Is it MRO? What takes precedence?
So yeah, MRO is the, I guess, the baked in Python logic that's going to determine what function is going to get called. So you are right, the MRO is going to be involved here. But since we created a same named method, this is going to override with a D the base method. So basically, this is going to mask the base method unless we call it manually. So again, override with a D means the base method still exists, but we're just creating something that sits on top of it. So that gets precedence instead of the base method. But we're not overwriting with a T because, again, we've not modified any of the base functionality. We're just creating extra functionality on top. So in this case, withdraw, what are our requirements? Withdraw. Each withdrawal incurs a $2 fee. Does not allow the account to go below 10. We'll output a warning. So I think I opted to raise an error last time, so we'll do the same thing here. So let's see. In this case, we should not call the base method first, because if we look at the base method, that's going to actually update our balance. We don't want to update our balance if it's an illegal withdrawal. So in this case, I'm going to call my base method second, but I still want to have that do its logic. But in this case, I'm going to check if, how do we do this? We might not need to call our base method then. So I'm trying to see if I could reuse this logic in our base. If we can't, then we can just implement it ourselves and not call the base method ourselves. So let's see, in this case, self.balance minus $2 if that's less than 10. And notice I'm using 10 here twice. This is a great time to create a variable for it, because this 10 and this 10 are the same values. It's going to work, but hard coding this value, if I want to change one, I'm going to have to remember to change the other. So I think this is a great time to, let's make it a class level attribute. So all savings account, we're going to say have a minimum balance. And that's gonna be $10.
Don't forget to put that inside the value error also.
Gotcha, thank you. I was gonna forget that. Great catch there. All right, so now we have a shared value. Minimum balance. Again, we use self
Minimum balance.
right here. Yep. We use self. We could use same as account. Can someone tell me what this does versus what this does? What's the difference and why might one be preferred over the other? So again, just to put that on screen, and I'm going all over the place here. We have a class level attribute called minimum balance. This works. This totally works. This is legit. What I could call savings account dot minimum balance because it's a class level attribute. I don't need an instance on it. But I could also call self dot minimum balance. Why might this be preferred over doing this?
If you want to
right.
set the minimum balance for an instance of savings account versus all savings accounts.
Yep, Sean's got it. Hypothetically, let's just make up a scenario. Let's say I'm a VIP customer and my bank's like, all right, just for you, we're gonna offer you like a promotion where your minimum balance can be $5 instead of 10. I mean, that's not a great promotion, but you know, they might want to specialize an account just for me. So in that case, they should have, like they being the bank, should have the ability to create a savings account object that has a different minimum balance for my particular account, my instance, versus everyone else's accounts will still default to 10. So having it as self.minimum balance, again, Python will check the instance first and see if there's an instance attribute of this name. If there is, it's gonna opt to use that. If there isn't, which is the normal case, it's gonna just fall back to the class level attribute. So again, that's why usually you wanna use, call it on self, unless you for sure know that you don't want it overridden. As in, let's say this bank can never implement an account with less than $10 for a savings account. At that point, the bank will be like, all right, we're not gonna let you override it. We're gonna mandate that we use the default that we've specified. Okay, so that's an implementation detail. There's not a 100% right answer, but usually you wanna opt to allow for overriding in that case. Okay, so we have that.
Withdrawals have a $1 fee and checks have a $2 fee.
There's checks. I was just looking at here. It's $2 fee. Checking account might have some other. Yeah, checking account has $1. So we implemented this checking account class, which I'm not going to do because it's going to be pretty repetitive. It's going to be very similar to this, except minimum balance I think is 0. Kind of scanning.
Yeah, I got lost.
So I guess we can overdraft here. So again, there might be some difference between checking account and savings account, but in that case, yeah, so there's still a fee incurred there. So I'm trying to think, would it make sense to create a related class for savings and checking account? Again, that's design decision. There's not a 100% right answer. In this case, I'm not seeing enough overlap between savings account and checking account. So I'm just gonna make them both account inherit from accounts instead of creating like an intermediary shared class that might have like a, you know, a fee here. So if we go and say withdrawal fee, it's $2 just to have something more dynamic in case we need to change it in the future. But again, like a checking account, to me, very, very similar to this. Withdrawal fee, not few, is going to be $1 instead of 2. So they both have class level attributes. There's no minimum balance for checking accounts, so that's a little different. But otherwise, there's going to be some differences. Again, I'm not going to go through this unless there's specific questions when you guys were attempting it. Anyone that attempted a bank account, do you guys want to see add interest or withdrawal using check? Was there anything in particular that you guys kind of stumbled on?
You hit both of them. One was like where do you do the account to owner assignment, and then 2 was like how do you manage the inheritance of the checking account and savings account?
Inheritance of savings account and checking account. So
yeah, like the methods, the withdrawal.
Yeah. So my my design decision is going to be these are going to both inherit from account because I don't see enough shared similarities here. Withdraw. Yeah, good question. I was struggling with that too. Is the question was, should we call the base withdrawal function? Because that's doing a similar logic, except it has a withdrawal fee. So trying to think. All right, I thought of an idea. This might I might regret this later, but I'm going to actually I'm going to give this a try. So I'm going to call super withdraw amounts and use a quad here just for my good reasons. So I'm going to have my base function have an optional fee that it takes in. So my base account method has a withdraw. Currently, it doesn't take in a fee, but we're going to have an optional fee here. So let's say fee equals 0, because it makes sense to default to nothing there. And then we're going to also subtract that. All right, so now this method can handle a fee if we pass one in. If we don't, it's going to default to 0. Let's see if this works. So I'm curious about the functionality here. So let's give this a try. Return super. I guess the problem here is that we also have a minimum balance, right? So maybe we want to create a class level attribute. Again, this might be something that I'm breaking my base functionality. I kind of just think about this, a minimum balance 0. And then it's not a self, it's a class level attribute. So now that I have this, I could probably use this here and probably use it here. Okay, now we made this more dynamic. Now that we have minimum balance as a class level attribute in our account, this can be overridden, which is actually overridden by our savings account to 10. So let's actually see how this pans out.
Line 40 in account. You have to subtract the fee as well.
Ah, yes, good catch, good catch. So let's do new balance. We're doing repetitive stuff here. Always good practice to not be redundant, just as proper design. So since I'm doing this subtraction potentially twice, I should probably just store it in a temporary. And there we go. So yep, that like if had I done this the first way, I wouldn't have had that problem that Sarah pointed out, in that where I changed it in one place, but I forgot to add it to the second place. Okay, let's give this a quick run. Probably some errors, but that's okay. Let's just create a savings account. So SA equals savings account. Does that import it for me? Hey, it did. Thanks. Savings account needs initial balance. So ID, let's go 1. Balance will be 20. Open date will be a string, and owner will be none. Okay, so runner file savings account. We're just creating a standalone savings account, not inside of the bank. We want to try to withdraw something. Let's hit our edge case right away. I'm going to try to withdraw $10, but we have a fee of $2. So that's going to actually take our balance, assuming everything is working correctly, down to 8. But that should not be allowed. So let's implement our try catch, obviously. There might be an exception there. So try doing this. If there's an exception, let's try to catch that here. And we'll just print it out. Okay, so we're going to try to withdraw $10. If my mind is working correctly, that should not be correct. That should not be allowed, because our fee of $2 will take us under 10, and our minimum balance for savings account is $10. All right, let's see what errors I have stumbled on this time. So we have Python runner. Okay, surprisingly got no errors. Cannot withdraw amount specified, so that is what I expected, except for this printout. That makes sense. Let's try withdrawing $5. So $20 initially, $5 we're trying to withdraw, but we get a $2 fee on top of that. So that should take us down to $13, which is kosher for a minimum balance of 10 that we need to maintain. Okay, so we got no error because we didn't return anything here. Just print this out. Okay, so it looks like it's working correctly. So notice our balance is 13. That's good. We try to withdraw again. So let's withdraw another $5. Obviously, that should throw an error because it's going to take us under 10. So this should work once, then not twice. So yep, we got 13, and then we can't withdraw specified amount. So Jack, I'm glad you kind of brought up that question because I was kind of gonna ignore it, but I think we made our design more robust, and you know, reusability has gone up because savings account is now just calling our base class. So in fact, we probably don't even need this method actually, now that I think about it. There's nothing that this method is doing that our method here is not doing. Yeah, so actually we don't need this withdraw method. We've made our base class robust enough where sure, we had to add one parameter that our base class is not going to necessarily use, but now, you know, this can handle both the derived class and the base functionality. So I guess I'm kind of getting away from what our spec file was or our requirements was talking about. But again, we have better code now here. We have less logic that's kind of handling it in both cases. So I removed the derived withdraw method, and it's oh, it does not work. So interesting. Let's think about that. So fee is always 0 here. So I think in this case, I want this back because we are passing a fee in this case. A way around this, can anyone think of a way around this? Let's say I don't want this function here. How can I still achieve the same solution?
On the runner.py file, you can just manually input the fee.
Yep, that is correct. We could manually put the fee here. That is correct. We could do that, but the problem with that is now our caller has to know what the fee is. That should be baked into the savings account automatically. Because again, hypothetically, let's say again, I'm a VIP customer and my bank's like, all right, we'll charge you only $1 when you withdraw. So then I got to keep track of that outside of my class or inside my class. It's better to keep track of that internally so that, you know, whoever's using your function doesn't need to know, hey, is this a special VIP customer that, you know, gets a special discount? They shouldn't care, right? That's again, encapsulation, that buzzword that we talk about often. So yeah, this would work, but let's think of another solution.
Can we set one just to be a constant in our class with the fee?
Sorry, I heard multiple people talking there. Don, do you want to repeat it?
Okay, can we set what appears to be a constant in our class so we can have a different fee for savings and checking?
It wouldn't be a constant, I don't think, unless I might be misunderstanding you. But I don't think we want a constant because again, savings account might have a different fee than a checking account. Which again, if we read our requirements, that's true.
That's why I said what appears to be a constant. But we want something associated with a savings account that's different than what's associated with a checking account.
Yep.
It could be
I think you're dancing around it. Yeah. So maybe to help you complete your thought. So remember how we added minimum balance to our account? The default minimum balance is 0. We can do the same thing here. Why not? Like our fee for our generic account is 0. Now that we have this fee here, our savings account has, I guess we should call it the same thing. We have to call it the same thing. It's not optional here. We need to name this class level attribute the same in our base class as with our derived class. Doing this allows us to override this value. So just let's be clear here. Withdraw, where are you? Right here. We have this fee value here. Instead of passing it in, we can just use account.fee. Why is this not going to work?
Is that account.withdraw fee?
Yep. Okay. Is this going to work?
No, because when you go to inherit it, it's going to try to, I think, grab the wrong fee and it'll error out because it doesn't have an account.withdraw fee. It's got a savings account.withdraw fee. So self would be better there.
Yep, Jack, you didn't fall into my trap there. So as Jack correctly spotted, I'm calling account directly here, right? So it's gonna look directly on the account for withdrawal fee because I'm specifying, hey, look in account. As Jack accurately spotted, this should be self. The reason this should be self is because our instance might have a special withdrawal fee. Again, I might be a VIP customer and have a special withdrawal fee just for my instance account. In the likely case, that's not going to be true, but the self still is going to appropriately go to the class, because that self is going to be a savings account instance. It's not going to have a withdrawal fee, so it's going to default to the savings account withdrawal fee here. All right, so let's actually see this in action to make sure I'm not lying to you guys. So correct way, I'm going to run it. That's because here. So I'm going to get rid of this method. I'm going to comment it out just in case stuff goes awry. But now this method doesn't exist. It only exists on the base class, and we're calling it on our savings account object. So again, this withdraw method is inherited. I've not overridden it in my savings account. So let's run this. All right, notice we get 13 and cannot withdraw amount. That's what we expect, because $5 withdrawal plus a $2 fee should give us a 13. Another $5 takes us under. Let's say you make that $3, and that still should fail, because again, there's still a fee each time we withdraw. It's $2 on top. Let's try the bad way that I was trying to do. So if I do account here, again, this is going to look for the withdrawal fee only on account. Let's see if we get the same results. Notice we get different values. Again, the reason is we sort of hard coded where to look for withdrawal fee instead of making it dynamic. We make it dynamic by starting with the instance, and that instance can, again, since that's a savings account type, it can automatically bubble up to the savings account class attribute. And if this didn't exist, like let's say we named it, X or whatever we named it, if this doesn't exist, it's going to then go down to our account level and look for that attribute there. Again, so there's all those levels. Instance gets priority, then the immediate class, and then any derived class, like each level beneath that. So there might be 5 derived classes underneath it. It's going to look in each one of those in order. And that goes back to the MRO, which was that complicated topic that we talked about last week. Okay, I feel like we spent a lot of time on bank accounts. Hopefully you guys aren't super exhausted by all that talk. I'm not going to do the specifics here about interest rate and checking withdrawal using check. Just again, kind of get to our lecture topic today. So with that, I'm going to wrap this up. But before I wrap it up, questions. What questions do you guys have? I will throw this up on some share in case you guys want to look at it. Again, no obligation, but if anyone wants to go over the lecture, watch the lecture again, wants to have access to these files, I'll definitely make access to it. Unfortunately, I don't have good commenting, so that's going to be not ideal. I'll try to.
Is that going to be able to? Is that going to be up by lunchtime? Would you say, or is it going to be later on this afternoon?
Yeah, I'll do it sometime around lunch. I'll try to either pull a pull request, even though it's an incomplete solution, but I'll put up a pull request on the bank accounts challenge there.
Awesome.
Okay. I definitely need a water break, and I'm sure you guys need to rest your eyes. So let's take a 6-minute break. Please be back by 11 a.m. and then we'll dive into our regular expressions lecture, which hopefully shouldn't take too long. So we should get to normal lunchtime if I'm not lying to you guys. All right, see you guys in a bit.